don't we kind of, because chemistry is a prerequisite for some other courses you might want to take, so you usually get chem done first. All right, so we left off just talking about bonding and how atoms form bonds to form compounds. And so we talked last time about the types of bonds. Covalent bonds and ionic bonds, which is really all we need to be concerned with for this class. Let's see if I go back here. Great.
No.
Hold it. Sure. So who could explain to me the difference between an ionic bond versus a covalent bond? Brandon?
The covalent bond is when they share like one of the electrons. The ionic bond is when they're attracted to each other because they're different
They have a different charge? Yeah, why do the atoms get a different charge? Because what did they do? Yeah, they either gave away an electron or they gained an electron. And that leads to them having a charge. And we know that having a charge means that molecules, atoms are attracted to each other. Positive and negative are attracted. So I guess we won't go back to that slide. So there are also times when two atoms can share more than one electron. Okay, they can share two electrons, a pair of electrons. And that's what we call a double bond. Okay? A double bond is when a pair of atoms is shared rather than one. And so one example of that is in ethylene gas. Okay? So this is the structural formula for ethylene. When we are depicting a double bond, we just draw with two lines connecting the two atoms. That's what that means. Okay? So we know carbon always wants to form how many bonds? Total.
4.
Always forms 4 bonds. Okay. Yesterday in our last slide we looked at methane, CH4, okay, where the central carbon atom and it's bonded to 4 separate hydrogen atoms. Well, here it's still forming 4 bonds. Okay, one with hydrogen, one with this hydrogen, and then it's sharing 2 with the other carbon. So that fulfills its 4 bonds, and it gives it that full outer shell, and so it forms a bond, a double bond. Ethylene gas is a gas that is responsible for fruit ripening. If you've ever heard the saying that if you have like some unripe fruit, if you put it in like a paper bag with a ripe piece of fruit, it will ripen more quickly. And it does that because the ripe fruit gives off ethylene gas, which causes the other fruits to ripen at a quicker rate too. Some fruits are picked unripe off of the plants they're growing on, and then artificially exposed to ethylene gas to enhance their ripening. For example, they can pick green tomatoes off of tomato plants, ship them where they need to go so they're still nice and firm and they're not damaged, and then they ripen them artificially with ethylene gas closer to the source where they're going to sell them. Okay, so that's what ethylene glass is. And the formula obviously is C2H4. Triple bonds can also form. Okay, acetylene gas is what's in like a blowtorch. Okay, and you see the formula for it here. We have a triple bond between the 2 carbons, and then each carbon has a single bond with a hydrogen atom. And again, that triple bond is the sharing of 3 pairs of electrons. And there can even be quadruple bonds. So carbon. If carbon has a quadruple bond, okay, with another carbon atom, it's sharing 4 of those electrons. They're each sharing all 4 of their electrons together. Okay? And that is, for example, what you would find in graphite, in diamonds, which are pure carbon compounds. Even though they look very different because of the way those atoms arrange themselves, they're basically the same chemical composition. Single bonds are generally stronger, okay, and they hold more energy. Remember, bonds store energy, and by breaking bonds, we can release that energy. And so single bonds are stronger, they're called saturated. Multiple bonds, like double or triple bonds, are unsaturated and hold less energy. If we remember back to what we talked about with, hold on one sec. Need help?
The video, I can't get it going. Thank you, dear. I'll babysit. How we doing, guys?
Great.
Chemical bonds, acids and bases.
It's magical.
It's magical. Is this seventh grade?
No, this is not.
Yeah, I'm in seventh grade.
Is this AP Bio?
Yeah.
Oh, I taught that for 40 years. What are you working on? Oh, biochemistry, my favorite. I loved it. Oh my God. It just kind of throws it at us. Okay, so were you on multiple bonds? Okay, so multiple bonds are weaker. Did I tell you that? They're weaker than single bonds. They break easily. Give you more energy too. So the more multiple bonds something has, the more energy you get out of it. What else? Carbon always forms 4 bonds, because if you look on the periodic chart, there are 4 electrons in its outermost orbit. That's how you can tell how many bonds it forms. Have you done any labs yet with acids and bases?
No, we're gonna start with
Okay, we probably will.
Wait, why are they weaker?
Why are they what?
Weaker.
Why are what weaker? The single bond, the saturated bonds?
Yeah, the one.
Because they're joining many other atoms, and it's like sometimes when in a group, it's not as strong as 2 holding tight together. You know, in other words, it's like a sharing. Okay, let me see. Is it going?
Yeah, the thing wasn't on.
That big box?
All right.
Yeah.
So if you think about what we talked about last class, is that what are the 4 most abundant elements in living? Oxygen, carbon,
Hydrogen,
nitrogen, John. And we know that these atoms generally form a certain number of bonds because of those valence electrons. Carbon generally forms 4 bonds, hydrogen 1, oxygen 2, and nitrogen 3. So let's talk a little bit about this concept of acids and bases. Okay? Because pH, which we'll get to in a few minutes, is a very important property to living things, that living things have to maintain proper pH levels. Because if not, enzymes stop working, chemical reactions stop working, and under those conditions, organisms cannot survive. So first of all, water, we know H2O. Okay? If we look at what a water molecule looks like, okay, it's a central oxygen and then 2 hydrogen atoms all bonded together. Okay? But water is an example of something that we call a polar molecule, and that these electrons are not shared equally between the oxygen and the hydrogen. Sort of like the oxygen pulls them closer to the oxygen nucleus. And you can see it's sort of indicated here. These electrons are closer to the oxygen than they are to the hydrogen. Okay? So what that means is one water molecule, H2O, although it's one molecule, one part of that molecule has a charge, and the other part of the molecule has the opposite. So what would have overall a more negative charge? What part of the water molecule? Yeah, the oxygen, because it's carrying these electrons are closer to this area. So this part of the atom is negative, and then these 2 hydrogen atoms that are bonded, they have a partially positive charge. We call that a polar molecule, where the electrons are not shared equally. And sometimes water dissociates into 2 ions, hydrogen ions and hydroxide ions. Hydrogen ions have a positive charge. Okay? Hydroxide ions have a negative charge. Okay? And the concentration of hydrogen ions is what determines the acidity of a solution. Now in pure water is what we call neutral in terms of pH. The concentration, these brackets around the ion mean concentration. So the concentration of hydrogen ions and the concentration of hydroxide ions in pure water are basically equal. And so it's neutral. When we have a solution that is acidic, there are more hydrogen ions than hydroxide. When we have a solution that is basic, or also called alkaline, then the hydroxide ions are greater than the hydrogen ions. Okay? When we talk about acidity, we're really focusing on the hydrogen ions. Okay? Something very acidic has a high concentration of hydrogen ions. Something that's very basic has a very low concentration. Okay? Also, we can neutralize, if we add an acid and a base, then the high concentration of hydrogen ions from the acid combined with the high concentration of hydroxide ions from the base, and they sort of cancel each other out. They neutralize each other. When we mix an acid and a base, what we end up with is basically neutral water plus a salt. For example, if we look at this example, we have HCl, hydrochloric acid, okay? Very strong acid, okay? And sodium hydroxide, very strong base. Okay? When they are combined, they neutralize because the hydrogen from the acid combines with the hydroxide from the sodium hydroxide to form water. And then the chlorine and the sodium, okay, they bond together, just form salt, sodium chloride. And so the adding an acid base neutralized and leaves the salt behind. We measure acidity using the pH scale. Okay? pH scale is basically specifies the acidity or alkalinity, how acidic or basic a solution is. The pH scale was developed in the early 1900s. We think of pH as potential hydrogen. And the pH scale goes basically from 0 to 14. So a low pH number means a stronger acid. A higher pH number means a weaker acid or a stronger base, with 70 right in the middle. The numbers actually come from, they are the negative logarithm of the concentration of hydrogen ions. Okay. So we don't have to worry too much about the math, but a logarithm, you guys learn about logarithms?
Yeah.
Never? No? Yes? Some people have? Okay. It's basically, the logarithm is what you raise a number to get another number. So for example, a pH of 5 means there is 1 times 10 to the negative 5th power of moles. Moles is a unit of concentration we use in chemistry of hydrogen ions. Okay? So pH of 6 means there's 1 times 10 to the negative 6th moles of hydrogen ions. We work out the decimals, okay? So a pH of 5 means we have 0.00001 moles of hydrogen per liter. pH of 6, okay, we have to add another decimal in there. It's 0.00001 moles per liter. Okay? So as we go down that pH scale, okay, at the very end, pH of 0, okay, what's 10 to the 0? 1. Okay, that means there's 1 mole per liter of hydrogen ions in that solution. And it also means that a difference, if you go from one number to another on the pH scale, it's actually a 10 times change in concentration. So going from a pH of 4 to a pH of 3 means not that there's just a 1 difference, but there's a 10 times difference in acidity between those. If you go from 5 to 3, it's 100 times more acidic. Okay? So it's an exponential scale.
Are you taking a break?
Not now. And when we look at some common, yes, in the fridge, some common substances, pure distilled water is a pH of 7. It is neutral. Okay? As we go to acidic substances, things like milk, coffee, we go down further, wine, orange juice, gastric juices found in our stomach, all the way down to hydrochloric acid at the one end, it's very acidic. At the opposite end, we have things like our blood is slightly basic. Seawater, slightly basic. Soaps and detergents are basic. Ammonia, bleach, the far ends, pure sodium hydroxide is a pH of 14. That's very basic. Okay? And we sometimes think that strong acid can be damaging. Well, a strong base can be just as equally damaging. For example, drain cleaners often and heavy-duty cleaners are very basic, and they can damage your skin if they get on you. Bases feel slippery in your hands. Like when you wash with soap, or if you ever got bleach on your hand, it has that kind of slippery feel. That's one of the characteristics of a base. Okay? And again, here you see some other common things like battery acids. Why when you're like jump starting a car with jumper cables, it's supposed to really protect your eyes and stuff. If one of those batteries explodes, it has very strong acid in it that can damage your eyes. And various other things you can see on this chart tell you the pH of various substances. We measure pH, and this is what our lab is going to be. Our next lab is about measuring the pH of different substances. And we use various indicators to do that. Okay? And here are some of the indicators that we may use. So phenolphthalein is a solution that starts off as a clear liquid. Okay? And when it comes into contact with a base over 9 on the pH scale, it turns red. Rhodothionyl blue is another indicator. It starts off blue. Okay? If it comes into contact with an acid with a pH of less than 7, it turns to yellow. There's paper that turns color. It's called litmus paper. It's basically paper treated with sort of these chemicals. And red litmus paper starts off red, but turns blue at a high pH when it comes in contact with a base. Blue litmus paper starts off blue and becomes red when it's in contact with an acid. And then there's some types of paper that will turn color when placed in a solution, and you can compare the color, and it will go from red on the most acidic side to blue, and it will turn different shades of colors that you can compare to a reference chart to see the acidity of whatever solution you're testing. For example, phenolphthalein goes from clear to blue. Okay. Rhodothionyl blue, again, you see at a pH, it varies. At a basic pH, it's blue, and then turns yellow as it gets more acidic. Litmus paper, there you have red litmus paper that turns blue when you put a base on it, or you have blue litmus paper that turns red when you put a drop of acid on it. Or you have the p-hydron paper, which gives you various levels of acidity, so you can be a little bit more specific.
Oh yeah, don't I feel like my mom.
Yeah, you might use it on your pool.
No.
No?
No.
Okay. But you may use it on the pool.
Yeah.
What is the pH of your pool supposed to be? Does everyone take care of their pool?
It's 6 points.
Is it?
I
I think it depends on the type of pool. Like a chlorine pool, it's slightly acidic. Does anyone have like a saltwater pool? You know what pH is supposed to be?
Those are awful.
Yeah, that's okay.
I don't like them at all.
I like them. I'm sure your house.
know.
There goes that pool party for the summer. Sophia?
Isn't it like can't you measure your pee with that?
Could
That's
you?
what-
You could.
That's
I
what
mean,
I've been told.
there's a lot. You could measure the pH of any basically liquid, and you could measure the pH of urine. But there's lots of
Why
tests.
would you though?
I
Sometimes
don't know.
there's like glucose test strips also, which if you test urine, that's what they do when you go to the doctor. If you have to give a urine sample, they'll use a little glucose test strip to see if there's too much glucose in your urine. And if there is, what might that be an indicator of?
Diabetes.
Yes. So there's all sorts of indicators that turn color.
I found this box
So
in my mom's bathroom,
yeah.
and it was like these little pH strips, and
Yeah.
then it gave you like that kind of graph
Could be.
that I didn't understand.
Yeah. All right. Any questions about that? All right, got a few minutes if you want to take a break, and we're going to move on.